So today's topic is non-parametric methods, part 2. Let's start with the sign test for paired data. The sign test is the easiest non-parametric test. Its name comes from the fact that it is based on the direction or the sign of a pair of observations and not on the numerical magnitudes. In such problems, each pair of sample value is replaced by a plus sign if the difference between the paired observation is positive. So I repeat, if the difference is positive, then it is replaced by plus sign. If the difference is negative, it is replaced by minus sign. And if the difference is 0, it is discarded. For applying the sign test to solve a problem, we count number of positive signs, number of negative signs, number of zeros, and then we take the two hypotheses. Null hypothesis, H0, P is equal to 0.5, and alternative hypothesis, H1, which is P is equal to not equal to 0.25. This is a case of two-tailed test. If you look carefully at the above two hypotheses, you will see that the situation is similar to a fair coin toss. If we toss a fair coin 30 times, then probability P would be 0.5, and we would expect about 15 heads and 15 tails. In this case, we would use the binomial distribution as the appropriate sampling distribution. We also know that when NP and NQ are each at least 5, we can use the normal distribution to approximate the binomial. Thus, we can apply normal distribution test. We calculate the standard error of the proportion P as given by standard error of proportion P is sigma P, which is equal to root under PQ by N. The two limits of acceptance region at 0.05 level of significance are P of H0 plus 1.96 sigma P and P of H0 minus 1.96 sigma P. It is important to note that if the conditions that both NP and NQ are not greater than 5, then we must use the binomial instead of normal distribution test. Let us use this example to clarify this test more. Use the sign test to see if there is a difference between the number of days required to collect an account receivable before and after a new collection policy. Use the 0.05 significance level. I repeat the question. Use the sign test to see if there is a difference between the number of days required to collect an account receivable before and after a new collection policy. Use the 0.05 significance level. Here is the table which is given before, after, and the sign of score, which is before minus after. I'm dictating the table: before 33, after 35 the sign minus, before 36, after 29 the sign is plus, and hence the table follows. Giving you 2 minutes to just have a quick review on the table. Let us continue. Number of positive signs is equal to 6. Number of negative signs is equal to 7. Number of 0 is equal to 2. So total sample size is equal to 15. When we use the sign test, we exclude the evaluation zeros as we are testing perceivable differences. We notice that we have 6 plus signs and 7 minus signs for a total of 13 usable responses. If there is no difference between the two types of collections, P, that is the probability, would be 0.5, and we would expect to get equal number of plus and minus signs. We set up the hypothesis as the null hypothesis H0, which is P is equal to 0.5. There is no difference between the collections. And alternative hypothesis H1, P not equal to 0.5, there is a difference. It is a case of two-tailed test. Now, sample size is equal to 13. Proportion P is equal to 6 by 13, which is equal to 0.46. Therefore, Q is equal to 1 minus P is equal to 1 minus 0.46, which is equal to 0.54. Here, NP is equal to 13 into 6 by 13, which is equal to 6. Similarly, NQ is equal to 13 into 7 by 13, which is equal to 7. These are both greater than 5, so we use the normal distribution to approximate the binomial. Number 2. Level of significance. Alpha is equal to 0.05. Number 3. Z alpha for two-tailed test is equal to 1.96, which is taken from the table. Number 4. Standard error of the proportion P is equal to sigma P, which is equal to root under PQ by N which is equal to 0.46 into 0.54 by 13, which is equal to root under 0.2484, which is equal to 0.498. Number 5. Limits of acceptance region. Upper limit UL is pH0 plus 1.96 sigma p, which is equal to 0.5 plus 1.96 into 0.498, which is equal to 1.476. The lower limit LL is pH0 minus 1.96 sigma p equal to 0.5 minus 1.96 into 0.498, which is equal to minus 0.476. Hence, number 6, the decision. The two limits of acceptance region are 1.476 and minus 0.476. The sample proportion P is equal to 0.46, which lies between these two limits. So the sample proportion falls within the acceptance region for this hypothesis. We accept the null hypothesis. There is no difference between the two types of collections at 0.05 level significance is our solution.